Hey guys, so here is our next standard. We're going to be talking more about Earth and our activities on Earth and how we're affecting the environment due to our activities. So, not last week, but the week before, we had Earth Week activities. And so now we're going to flash back a little bit and do a little bit of work on the environment, thinking back to some of the stuff you did 2 weeks ago. Alright, so this is standard ESS32, and it's Earth and Human Activities. Alright, so these notes, you're just going to fill them in, and what you should do here is you can either print them if you have a printer, or I would just open the Word document and pull it up side by side, split your screens, and type this in as you go. If you do that, please use a different color font so we can see, and then you're going to upload these and save them. It's 4 pages, and I'm going to do it in 2 videos so that they're not extremely long. And if you print them, I did try to make it like fun so you could color it in if you wanted to just have little doodle notes, as they say. Anyways, here we go. So what is the greenhouse effect? What that is when sunlight passes through the atmosphere and warms the Earth's surface. The heat hits the Earth and then radiates back towards space. The greenhouse gas molecules in the atmosphere absorbs most of the heat and then sends the heat in all directions. This warms the surface of the Earth. There's 3 types of gases that we talk about when we talk about for greenhouse gases: water vapor, carbon dioxide, and methane. So greenhouse gases make a thermal blanket around the Earth, and what happens is they trap that heat in. The more greenhouse gases there are, it means heat is absorbed and Earth is warmer. So we are trapping them in. So the picture here is basically showing you what I just said in words. The sun radiates down, hits the Earth. About half of it is absorbed on the Earth's surface and warms it, and then some of it is bounced around. And because of the gases, though, they can't escape back out. All right. A greenhouse gas, such as carbon dioxide and methane, that absorb radiation from the sun and trap the heat in the atmosphere, is what a greenhouse gas is. Global climate is the range of weather that varies from region to region, so like across the globe. Global warming, an increase in temperature of the Earth's atmosphere caused, I chopped off a word there, by gases and pollutants. Because of that, there is climate change, which is a change in the region's weather conditions. And then things that help increase the gases and pollutants would be the burning of fossil fuels, and fossil fuels are natural fuel formed from the remains of living organism. Includes petroleum, or what we call oil, and coal and natural gas. So the burning of those fuels releases gases and pollutants into the atmosphere, and that is contributing to global warming. All right, on this paper, it's divided into 4 sections, and so we're going to talk about each section. Sea level rising and the decline of sea ice. So all 4 of these are basically giving us evidence of the global climate change. So with sea level rising and the decrease of sea ice, global sea levels have risen 17 centimeters in the last 100 years. This is double the rise in the previous 100 years. So it means it's happening more quickly. The size and thickness of the Arctic Sea ice has decreased. And so we're going to look at a picture here in a second, and you're going to see how the ice has decreased. NASA data has shown that ice sheets in Greenland and Antarctic have also decreased. And so looking at this picture, this is 1909 and 2004. The bottom one, that stuff that looks white, even though it's a black and white picture, but you can see that one is lighter or grayer than the right-hand side, is grayer than the left-hand side. That's sheet of ice or ice caps, okay? And if you look at 2004, that's gone. It's not there anymore. Look at how high the ice cap goes over here, okay? And look at where it was. Like, that was almost the top of that mountain range back there, and look, it's not there anymore. So this right here is ice cap. And this, sorry, I got ahead of myself, right here is where it used to be. So that is a decrease in Arctic ice. Okay. Extreme weather events. So the intensity of the North Atlantic hurricanes has increased in frequency and intensity. Just think about previous hurricane seasons. They're becoming more and more frequent, and not the seasons, but the hurricanes. And their intensity is stronger. Think about the one that hit Houston a couple years ago and how horrible that was, and other recent hurricanes that have caused mass devastation. So those are increasing due to, in some parts, to the change in precipitation patterns. Temperatures rise, and when that happens, more moisture is evaporated, and that brings more, rain or snow. I chopped off the word rain, sorry. Let me see if I can fix this. Rain. I lost it, sorry. Bringing more rain or snow. This is not spread evenly around the globe. Some areas get more precipitation and some areas will get less. Think about the wildfires in California the last year and previous years. Think about the wildfires in Australia this past year, this past fall, how horrible that devastation was. That's because they're not getting the rain they need. And so therefore, and it's hot and a fire starts and they can't get it under control. So those are results sometimes from the change in this precipitation pattern. All right. The rise of global temperature. So the number of record high temperatures has increased. And then looking at this chart, I want you to circle or highlight or underline the title of this chart. Everyone find it? So average global temperatures, that's the title. And then I want you to look at the x-axis. Does everybody know where that is? That's down the bottom. I want you to write the word years down there because that's what the x-axis is labeled. I cut it off accidentally, sorry. And then the y-axis is degrees in Fahrenheit. So highlight that. And then what you see happening here is from the 1880s all the way to 2020, you can see that there is a general increase in the average temperatures, okay? And if you're looking at the numbers on the left-hand side, they're not huge. It's not a huge range, but it's showing you the peaks and valleys and how it's increased over time. All right, and then we have ocean acidification. And so what that means is the acidity of the surface ocean water has increased 30% since the Industrial Revolution in the early 1800s. I'm talking about coral reefs in a second. The ocean is absorbing more and more carbon dioxide every year, which is increasing the acidity. If you remember when we did the Elodea plants and we had the blue speakers, and we had some in light and some in dark and direct light and all that stuff. Remember, we were testing how the acidity of the water to see if there was oxygen or carbon dioxide being released in there. So that is sort of what's happening, an example of this happening here. There's too much carbon dioxide being released, and it's being absorbed more and more into the ocean, causing the acidity level to rise, which is causing coral reefs to be bleached, and which is killing and damaging those ecosystems and destroying the area for all those animals. Alright, I'm going to stop here for this video, and then you can click right over to the next one and keep going on the rest of this if you want to, or you can do the rest tomorrow. It's up to you.